Welcome back to my channel for a short Leica episode, again about the Q3 43, which newly came to the market. I have it here in my hands. I'm currently carrying this camera with me wherever I go, and I must say I love it. I love 43mm. I think this is a perfect focal length for street photography, for reportage, but also for landscape, for people. It's widest open f2.0, and most importantly, this is not a Summilux lens as we had on the Q3 28. This is an Apo-Summicron, and what I want to do in this video is I want to show sample images which I got when I did shoot this camera and this Apo-Summicron in the macro mode. And I want to provide also some tips and tricks and some technical background, of course, on macro photography with a Q camera, which technically speaking is not really macro photography, but rather close-up photography. And of course, in the sample images, you will see what you can do with this camera. The question I really want to answer is, if we talk here about close-up shooting with that camera, is it something you can really use, or is it a gimmick which is just built into that lens and into that compact full-frame sensor camera to impress people? Alright, so getting into macro mode is simple. You turn the macro ring. The scale here changes on the distances, and you are then in a close-up shooting situation. To go back, you simply rotate it back. Very simple. What you see here, if we look at the near distance, this is the minimum focusing distance. It's actually 0.6 meter in the non-macro mode, so in normal shooting mode. And if I switch to macro, it's 0.27 meter, so 27 centimeter. I come back to that later in the course of the video when I provide some technical background about shooting macros with Q cameras and macro shooting in general. You actually can experiment with the minimum focusing distance very simple. So I'm now in the normal shooting mode, and I'm sitting outside and staring here in front of me into the flowers and plants. And these pinkish red flowers, they are just not far away enough in order to find focus. And I showed before it's 60 centimeter, what the camera is showing here on the minimum focusing distance. If I focus to something more in the background, of course, the camera will find focus. And that's how the minimum focusing distance is working. If I switch now into the macro mode, I have a minimum focusing distance of 27 centimeters, so it will actually get the focus sitting on the pinkish red flowers here. Now, what happens if I start to rotate the macro ring? Look at the screen here. I get a message, macro ring not in correct position. So I cannot accidentally overlook that the ring is not correctly returned. So if I continue to return the ring, it actually gives me back the live view. And now I'm in macro mode, and I can also focus on these flowers here. You see that? Because now I have here a close-up distance, a minimum focusing distance of 0.27 meter. So that's the way it works. What's also interesting to note is that my aperture setting here on the aperture ring is an f2.0, and I'm in normal shooting mode, and the camera recognizes here the f2.0. But if I switch now into macro mode, let me rotate the macro ring, it switches automatically to an f2.8, although on the aperture ring it still has a setting of f2.0. So the camera is just ignoring the setting here, and the widest open aperture you can use in macro shooting is actually an f2.8. And if I remember correctly, all my sample images have been shot with an f2.8. Now, my tip for macro photography, in particular if you go for insects and bees, is on the settings the following. First of all, I want to make the shutter speed very fast. So I switched here to 1/1000 seconds or 1/2000 seconds. And I let the ISO freely float. It's not a problem to shoot with a 2000 ISO if the daylight is not bright enough with that camera sensor in the Q3 cameras, because these sensors are not really vulnerable to noise, and you can basically hex it away later in Lightroom with the noise reduction filter. So that's the first setting. And in this way, even if the wind is blowing and the insect is moving very quickly, and bees can be very quick, with a 1/2000 seconds shutter speed or 1/1000 if you don't want to overdo it, you will be on the safe side. The second setting, which I used most of the time in my shooting, is here on the autofocus. I really went to autofocus continuous because I wanted the autofocus to track the bee and the insects when it was moving. And I also went here into tracking mode. So let me go here, not to eye, face, body detection, not on animal detection. Let me go back here, sorry. Not on animal detection, but here just on tracking. And what happens is I also have a setting activated which says tracking from the center. So my focus field is now in the center, and then it starts to track. I hope you can see this here. It gets sticky on where I was the focus sitting at first place, and that helps a lot if you shoot insects like bees. And it's kind of the same as if you would go for people photography, and tracking is really something that helped me to catch the images I'm going to show later in the video. In terms of minimum focusing distance, which is the 27 centimeter here, I'm typically experimenting. So I go as close as possible to my subject and see if it still can find focus. And you see I can go here very close and it's still turning green in the focus field. Now it's not finding focus, whatever, here we are. And this is just experimental. I, of course, do not have a yardstick with me to find out whether I'm just far enough away to match the 27 centimeter here. I'm just experimenting by moving close to my subject and then trying to get the shot, which worked very well for the bees, as you will see in a moment in the sample images. Strictly speaking, this is not a macro mode. In the definition I'm used to, macro starts with a magnification or reproduction ratio of 0.5. And then in, let's say, the better macro lens is typically a 1:1 100% magnification or even higher. So what I want to do now is I want to provide some context about the magnification ratio of that lens, how to calculate it, and how it compares with the Leica Q3 28. And that will be a bit technical. I will make it short, but I hope it's useful for you. All right, let's go into the technical part of my video, namely how to calculate the maximum magnification ratio, so we get a sense of how much macro really is that Apo-Summicron on the new Leica Q3 43. And first of all, there are different ways to get to the same result. I will follow a path where you use the minimum focusing distance and the focal length of the lens to come to the maximum magnification, or as some people say, reproduction ratio. And the formula is the one you see here in the center of the slide here on display. And it has only the two parameters, the minimum focusing distance. You can just calculate straightforward what the magnification ratio is. And we have for the Leica Q3 28mm, of course, a 28mm focal length and a 17 centimeter minimum focusing distance. And for the Leica Q3 43, we have 27 centimeter minimum focusing distance, and we have a focal length, of course, of 43mm. That's why it's called the Q3 43. And if we plug this into the formula, we get a maximum magnification ratio or reproduction ratio in the close-up mode for the Q3 28 of 0.26 and for the Q3 43 of 0.25. So in terms of magnification, the older Q3 with 28mm Summilux lens has a little bit of an advantage, but you can safely say that this is about the same magnification. Now, of course, if you look at these formulas, this looks a bit messy, and I, of course, did not plug this into a calculator, but used, as always in my more technical videos, Wolfram Alpha to get the calculations done. And you see in the lower left-hand side corner, 0.2625 is the exact ratio for the Q3 28, and that in rounding gives for me an 0.26, and on the Q3 43 we have 0.2480, and this is the 0.25 times magnification I had here on that presentation slide. And strictly speaking, and I've done the test here and just asked ChatGPT 4.0 what actually is a macro lens, and the general common sense is that the macro lens should reproduce in a 1:1 ratio. So whatever the size is of an item in front of the sensor, if you go to the minimum focusing distance, it should be represented in exactly that size in the image later on. And I think the more general definition, a bit more relaxed definition, is that from a magnification ratio of 0.5 on, this is considered to be a macro lens. So let's have a look here. Here's an image I did shoot with the Leica Q3 43, and you see here the watch in front of me on the image. Now, if we measure the size of the watch, it comes up with 4 centimeter, and the precise measurement, if you look this up on the technical specifications, is actually 42.2. But let's work with 4 centimeter for the time being, so I can explain what reproduction or magnification ratio really means. If we look at the image dimensions in terms of sensor size, it's a full frame sensor, so we have 36 times 24 millimeter. Let's focus on the vertical direction of 24 millimeter. If I now want to test how often would that watch fit into the vertical direction of the frame, which is the frame of a full frame sensor, then this is about 2.4 times. Let's verify this by copy pasting the watch in vertical direction, and let's stack the images, and you see is about 2.4 times. So if we now divide the vertical dimension of the sensor of 24 mm by 2.4, we end up at 10 mm. So it's safe to say that the watch in vertical direction is about occupying 10 mm of the frame here. If we then do a little more math, we find that 10 mm divided by the 40 mm, which is the true dimension of the watch in real physical life, we come to an 0.25 times magnification, which is what I calculated before. So you can also experimentally figure out what the magnification of the lens is, and it basically means that 40 mm in real physical dimensions of the watch in vertical direction appear as 10 mm on the sensor. That's what this is all about, and that's in terms of technical background what I wanted to quickly provide, so you better understand what I'm talking about when I'm mentioning magnification ratio or reproduction ratio of the lens. Let's now look into sample images, and let's do this quickly, but let me making my points, which I think are important to contribute to the discussion here. So first of all, you see flowers here. We have very nice sharpness, crispiness where the focus is sitting. We have a nice dreamy background bokeh here. All these images have been shot at widest open in macro mode, f2.8, and they are all shot with 1/1000 seconds or 1/2000 seconds because the wind was blowing on that day when the images have been taken. And look at that, sharpness, color rendering, micro contrast, contrast in general looks really, really good on that image. More flowers, nothing to say here. This is a nice image I like a lot. Look also at the circular background bokeh lights here in the upper right hand side corner. Quite nice. This is really an Apo-Summicron feeling impression I get here when I look into these images. Then we have some insects here, and this is, if I'm not mistaken, I'm not a biologist, so apologies if I do not get this right. I believe this is a hummingbird hawk moth, and this is getting, of course, nutrition here from the flowers. And if you look into that, this is a deep crop. This looks really good. Almost frozen in with 1/1000 seconds in the movement. Here we have a bee, 1/2000 seconds, nicely separating the bee sitting on the flower from the background, which is super blurry. Widest open at f2.8 in macro mode here, and is a really nice image, I think. Again, color rendering, contrast, micro contrast, everything of this image is an Apo-Summicron type image. It looks really good. It reminds me a lot of what you can achieve, for instance, with Leica M cameras and Apo-Summicron lenses in that portfolio lineup, or with the Leica SR3 and Apo-Summicron lenses there. It looks really, really good. Here another bee, I want to talk about that for a moment. So this is a deep crop now, and if you look at the resolution of the image, about 1800 times 1200 pixels, this means, if I calculate this correctly, about 2 megapixel, so it's not a lot. And what if you want to print that image in large dimensions? Well, then you scale it up by some software, and I used here Gigapixel AI from Topaz, and I scaled this up from about 2 megapixel to 33 megapixel, and it looks really good. And now you can also crop in and get a nice representation of that bee here, and this is definitely possible now to print this in larger dimensions and get it on the wall. So a very nice picture. And let's for a moment think about, why do I need to crop in that deeply into the image? Well, because if you have an 0.25 times magnification ratio and the B is, let's say, 10 millimeter, that means on the sensor in the representation it will only be 2.5 millimeter. So from 10 millimeter in physical dimension into 2.5 millimeter representation on the sensor. And that's why I needed to crop in deeply here. But then scaling it up from 1 to 2 megapixel to a 33 megapixel image is not a problem at all. It looks really good. It is sharp and crisp, and there is no pixel structure recognizable if you do this with the right software. So that's what you can do, of course, if you want to go into serious product and macro photography here. Another bee, also a nice one, and here we have again that hummingbird hawk moth, and you see here how this is sharply represented, but even at 1/2000 seconds these insects move so fast that is almost impossible to completely freeze them in movement, but I don't care, it's nevertheless an interesting image. Flowers again, look at the interesting representation of the background bokeh here again, f2.8, 1/2000 seconds, very sharp, very crisp, colors nice, very natural in the way it comes across. Look at this one here. You see it's just very sharp here where the focus was sitting, and then a very shallow depth of field. More flowers, more flowers. These are nice pictures cropped in also, and the sun was actually shining through the leaves of these flowers from behind, which gives them a certain glow. I like that a lot. Here another image. I don't want to go into that. Here again, that hummingbird hawk moth. And if you look at that, here is very sharp, very nicely represented. I think that's it. That's almost all I wanted to show. Oh yes, here is one where I actually managed to freeze the movement when this insect was flying here. And you see how sharp and crisp this is at 1/2000 seconds and widest open in macro mode at f2.8. Quite nice. Last but not least, the watch. Don't get concerned about the bezel of that watch. It looks like the watch is rusty. It's a stainless steel watch, but it's actually not. This is just a reflection of the structure and the texture of the table underneath. And so this watch is in perfect condition. And if you look at that for product photography, it looks really nice. Look at the blurriness in the background. Look how the watch is separated in the foreground from the background. Look how sharp this is if you crop in to 100%. And I think for product photography, for macro photography, and then maybe using some additional tools like Gigapixel AI from Topaz or any other tools, I do not promote any tools here. This is a serious tool, a serious instrument for product photography, macro photography, if you consider that Apo-Summicron lens on the Leica Q3 43. All right, that's already it. And I hope I could convince you that this lens, shot in macro mode, but also in normal shooting mode, really deserves the attribute Apo-Summicron. It's a pinpoint sharp lens, and the images are just astonishingly sharp and very well done in terms of contrast and micro contrast. And what you can also do, of course, as I showed in the section about the sample images, you can scale them up. You know, if you crop in here based on the not so high magnification ratio of 0.25, and you crop in deeply into the image to, for instance, set an insect or a bee in scene, you can scale them up by Gigapixel AI or other software. That's by chance the one I have here on my MacBook. I'm not promoting for that, but it works always pretty well for me. And you can scale them up and get better dimensions for larger dimensional prints. And that means for me that the macro mode on this Q3 43 is not only a gimmick. It's not there to impress that you can get a bit closer, you know. Instead of 60 centimeter here, you get as close as 27 centimeter and will still find focus. It's really a professional tool for close-up shots, product photography and macro photography. And I think Leica has done a good job integrating this into here. I think it works even better for me, although it has a tiny little smaller reproduction or magnification ratio than on the Q3 28. Because on a wide angle lens, I think macro is always a bit more tricky to use than on the lens with a normal focal length. If you liked that video, don't forget to drop me your thumbs up. Stay tuned on my channel, there's always more to come. Thanks for watching, stay safe and healthy, and of course, peace out.